In our last class, we were working on literal equations, equations that contained more than one variable, and we were isolating one variable in terms of all the others. And we started off with something we were familiar with, just solving for x, and then I started one by one replacing numbers with variables so that you would get the idea that it was very similar to what you already know how to do. Not very similar, but actually what you already know how to do. So let's just do a couple of quick problems before we move on to the next part of the lesson. In this problem, I'm looking at a literal equation because it has, again, more than one variable. They're asking me to solve for b, so again, as I did last time, I'm just sort of going to put a little marking here so I know that that's what I'm looking to solve for, which means I'm going to use inverse operations to isolate that variable b. So step one is let's subtract 12c to both sides. We're using our property of opposites for our inverse operations to isolate b. Now I have to divide all terms by 5, and I can put it just simply like that, and I get b is equal to 9 minus 12c over 5. If it could be simplified, I would, but this one can't. We then take a look at one that has all variables in it, and our goal once again is to solve for v. So v is attached right here by multiplication with w. Before I do that, I'm going to first subtract z on both sides. So I have u minus z equals v times w plus z minus z. These z's on the on the right will cancel out, and I'm left with u minus z is equal to v times w. If our goal is to get v by itself, we need to divide by w, and our final is v equals u minus z divided by w. Now, when we were last together, one of the other things we talked about was what happens if that variable that we're looking to isolate occurs on both sides of the equal to sign. We did the bottom one, but I did skip and said I'd come back to the top. I'm looking at this problem and I'm thinking the first thing I'd like to do is start moving things away from the variable that I'm looking to isolate. Now d is in both parts. Now these are greater on the right, so I'm going to move everything away from that. So I'm going to start by adding 1. Let's add 1 to both sides. I have d plus 5c plus 1 equals 3d. Let's now gather those d's to one side. Let's subtract d on both sides. And that leaves me with 5 times c plus 1 is equal to 2d. And the very last thing I will do is divide everything by 2. And I've now isolated d, and I've got 5 times c plus 1 divided by 2. So when I see that it occurs on both sides, I simply gather them to the side where they're greater so that I have positive values there. So that was just a little refresher on how we looked at these literal equations. And we said that literal equations, one particular form of them, are called formulas. So a formula is a type of literal equation, and it usually is something that helps us to solve a real-world problem, like finding area or perimeter in these two cases. In my first one, I want to solve for b. I know the area, I know the height, but I don't know the base. One inverse operation will get me to the base. Base is now equal to the area divided by the height, and we may have already done a few of these. Second one's a little bit more complicated. I'm solving for L, and L is right over there. So now let's take this, and the first thing I'm going to do is to subtract 2w on both sides. So we'll have p minus 2w is equal to 2 times the length. And if my goal is to get length by itself, I'm going to divide both sides by 2. So length is equal to the perimeter minus 2 times the W, which is the width, over 2. That can be simplified a little further, or you could just leave it like that. Now, why are we learning how to do this? Because sometimes you're given information and you're asked to solve for a particular variable or a particular component. When using formulas, though, we need to be sure that we're using something called unit analysis. We need to tell you if we're looking at feet or money or inches, what kind of units are we describing? What were we solving for? So in the circumference of a circle, pi is equal to circumference, sorry, circumference is equal to pi times diameter. I would just find the diameter by taking the circumference and dividing by pi. So in this particular case, if I'm looking for diameter, we know that this is 24 square feet, and pi can be written as 3 and 1400ths. We would divide and we get the diameter. But remember, when we get that diameter will be measured in feet. So we'll find out how many feet. Those are what we call the units. And that's a simple division, and I would use my calculator to find that answer. We might look at another problem using the distance formula. Distance equals rate times time. If you're given the distance, okay, 120 miles, and you're told that you're going to travel 60 miles per hour, let's find how long it's going to take you to get there. So we're solving for time, so I divided both sides by the rate. I rewrote that literal equation. So time is going to be equal to 120 miles divided by the 60 miles per hour. And what is that giving me? Time. And that time will be 2 hours. Again, it's critical that I tell you that I'm looking at hours and not miles per hour and not miles. Knowing the rate, the unit analysis to tell me what I'm looking for. So these are just a few different applications of this. We'll go into some more detail in our next session as a review.